Hello?
This, me
Okay,
this meeting is being recorded.
sure. Okay, let's get started. So first, thanks everyone who's joining us today, and I'm Fog, today's host. So I sent a Google Doc link in the comments, and that's our agenda documentation. So please help to sign up in the doc. Thanks a lot. So into this meeting, we're gonna have three parts here. So first, I'm gonna give you a demo of how to use workflow on ValueX to upgrade your application with the newly built image and with image scan. And after that, Da will first give an introduction to Vela Adopt, which is a new feature in our version 1.7. And he will also show some demos of how to adopt resources and Helm charts. And and after that, he will also give a brief introduction of our new released version 1.7. So first, I'm gonna give you a demo. Wait a second.
Yeah, just for some more information, because I think we have got lots of new people here today. So the meeting is pretty, freedom. So you can interrupt us if you have any questions and would like to ask. But usually every community meeting, we will have some introductions for new features or latest progress for KubeVela. And we will also have some discussions for the future plan and also any suggestions for the feature that we would like to add in the future. So that's free for everyone to welcome to everyone, and thanks for the join, and just let us know if you have any questions. Okay, that's all.
Yeah, thanks for the introduction. Yes, our meeting is very free, so if you have any questions, feel free to ask. So my demo today will show you how to use ValueX together with our new feature called Pipeline, which is a standalone workflow that released in version 1.6. I will show you how to use them together to first build your image and scan your image, and finally use this newly built image to update your KubeVela application. So first I'm gonna run this pipeline, this pipeline template here. So because image building will take a long time, so let's run this first and I'll give you explanation after that. So here I will create a new context. The context data will inject into the execution of the pipeline. So here we add an image version 4 with key image, and the value here we change it to v4. And we can use this context data to execute this pipeline. Okay, so now the pipeline is running, and I can show you more details of this pipeline. Okay. Okay, so the network is not good. So wait a second. So here we can see there are 4 steps here. And for the first one, it is called build push. And in this step, so this is the new step type that we provide in version 1.7. In this step, we can use a canonical. We actually use canonical for image build. So here you can choose some properties like the image name. So here I use an image placeholder here because the image will actually replaced by by the image data in context. And here we use the default canonical executor of the OAM image. And also there's more context here. I think the display is not good because here we actually is git URL and the branch of the git. So so this step will try to build image from your Git repository. Oh, okay, we can see the YAML here. So the first step here is to build image from my Git repository with main branch. And it will also use the credential because we need to push this build image to our repository. And it actually the image here, the image placeholder here will be replaced by our inputs, and the inputs is from the context.image that we just specified to run. And after that, I will use this newly built image to apply a new application. Actually, update this application because I already applied the application before. So in here, I will this application is a simple application with web service component and an exposed service, and this application's image here will also be replaced by our inputs from context.image so that we can update the image of the application. And after the application is applied, we will then use image scan. So the type here is trivy check, and actually this is a step definition that we provided in our add-on called trivy operator. So if you want to use this trivy scan capability, then you need to enable the add-on. So here, the trivy check step will actually try to scan all the vulnerabilities in your image and will output the uh, scan result to output. And the last step here is a notification. So if the image is scanned, we can get the report in our notification. Here, I will send the notification to my Slack. So yeah, that's all of this pipeline. And okay, so now the pipeline is success, we can check out the logs here, the real execution here. So you can see that the execution time of every step, and for the first step, we can also check the logs here. Because we actually threw a pod to run the canonical executor, and we also set the log from this pod in this step so that we can see all the logs here of this step. Okay, so the application is in version 4, and we can check out my app here. This is the app that we just applied in our pipeline, and in the default environment. Okay, so so the network is not good. Actually, we can see some service type here, but it needs some time to connect to the cluster. All right, so this app is actually using our so the service endpoint is up, and we can check out the application. Yeah, so this is the image that we just built with our code in the repository, and we also send the trivy scan report to our Slack. So can you guys see my Slack? Maybe yes.
Yes, we can see that.
Okay, so this is the report that we just received. So here the report shows that it's a trivy scan result for our version 4 image. So we can see all the summary here with all the critical count or high count of this image. And there are some details for every critical vulnerability. For example, here some CVE here, and we can also click the link to see which one is the CVE. So actually this, so if you want to like update your application, you can use this or like manage your application in different environments or different clusters. You want to orchestrate your application. Pipeline is a good choice for you to use. You can also, despite for this application orchestration, you can also add some single CI steps like image build or a trivy scan, or like apply resource in apply configuration in your cluster. So whatever you want, you like to do in your application workflow, you can also do it in the pipeline. So basically that's all of my demo today. So if you have any questions, please feel free to ask. Yeah. Okay, so if there's no questions, we can jump into the next part. Da, can you share your screen?
Yeah.
I have a question actually.
Oh,
Okay.
please.
Yeah, so I saw that in the pipeline you have a step, I think the type is called apply app or apply application. Is there a way to make reference to an existing app instead of having like the YAML there?
Oh, I see. So now we can actually apply this step called apply app can actually read your application YAML from a config map. But I think it's better for VelaUX users that if we can use this apply app step to apply an application in the VelaUX application templates. So this is what we need to do in the next step. If the step can apply the application in VelaUX, can it satisfy your need, or you just need to apply it from like read the YAML from the config map or something else?
Yeah, actually, well, I think maybe the config map. Yeah, I just remember that I was going through the documentation and yeah, I forgot about the config map. So yeah, maybe the config map can work. So I'm gonna test it, but yeah, thank you.
Okay. I can send you a link for the read app, for the apply app from a configuration config map in the Slack or the chat. But next we can have that to show your demo of Adobe application.
Yeah. Okay. I think before I start with the demo for the can you see the whole screen?
Yeah.
Yeah, okay. So before I start with the demo, I would like to show you some introduction for the latest release of KubeVela, which is version 1.7.0, which we just released several days ago. So in this version, we do not have too much big changes for the core controller, and most of the features and fixes are enhancements and to optimize the user experience. And we also make some progresses for integrating the authentication part with the VelaUX with better user experience, although it is possible to use it in the Vela core. So generally, this version we will have some small light new features, and there is no much extra burden for you to upgrade from version 1.6 to version 1.7. Okay, so let's go over and see what we have new in version 1.7. So one of the most important feature we would like to introduce is that there is a capability called workloads adoption in the newest version. And for the workload adoption, the intuition of this new feature is like sometimes we found that users already have their workloads running in the Kubernetes cluster, such as there are already deployments running in the cluster, or you could have pods or stateful sets, or even other advanced workloads running in your cluster. And sometimes user might want to have some easy way to migrate from the old Kubernetes use style to the KubeVela system, so that they can use application to model the underlying resources and manage them. To this point, we do not have a very easy way for user to do that. Although it is possible for user to concurrently have standalone workloads and also have some workloads managed by application at the same time. But in this version, we add some new enhancements that allow users to do very easy migration from existing ones to KubeVela application. So there are two parts. One of the parts is from the server side. So from the server side, we have two new resource policy. One is called read-only, and the other one is called takeover. So what they mean to do is just the literal meaning of this policy. So in the read-only policy, you can specify which resources in the application should be marked as read-only, and the application will not try to modify these resources under the read-only policy. And for takeover mode, it means that the application can ignore the owner check for the underlying resources and directly to handle those underlying resources and treat them as its own resource. So that when you have some existing workloads running in your cluster, you can either use the takeover mode, which means that once you use the takeover policy for your application, it means that the underlying workloads will be set with the new owner label that points to the latest application you are using it. So that the workloads will be completely adopted by the new application. But sometimes we find that the users might only want to have some observation for their underlying resources, and they still want to use the old styles to manage those resources, such as directly using the YAML manifest to deploy the workloads. But on KubeVela, we have a unified observation entrance for these resources, such as from the CLI part, we have the vela top, and from the UI side, we have also the vela UX and the resource topology graph. So for the add-on part, we can also use the Grafana add-on to have a application dashboard for them. So even if you do not want the application to handle the life cycle of the underlying workloads, it is also possible for KubeVela application to build a monitoring group for the underlying resources. So that's why we have these two new policies to achieve that. In addition to the server-side policy, we have also the CLI commands, which named as vela adopt. And with this vela adopt commands, it will recognize the resources you specified, especially if you specify some helm release, and it will automatically analyze which resources are embedded in that helm chart, and then converts them into a new application, so that you can use the new application to build, to initialize what you want to manage. So later I will have a very short demo for this CLI command. And this is one of the most important feature we introduced in version 1.7. And after that, we have some enhancements. For the controller part, we modified some default values for the KubeVela's controller, which can help users to optimize their performance while using KubeVela system. For example, there is some compression defaultly enabled, including the resource tracker and the application revision. So in the past, we find that the application revision and resource tracker, which embeds all the resources that one application manages, could take lots of spaces in the etcd database. So since 1.7, we default enabled the ZSTD compression algorithm so that the storage of these large objects will be greatly reduced. And in our estimation, the reduction ratio is about like around 70%. So it can greatly increase the capacity of your KubeVela system. And other things, we find that since there is no much user directly using the application revision for rolling back application and rollout application. So we set the default definition revision limit to a smaller one so that we can also save lots of storage for the etcd. And also, since we have the informal cache in the KubeVela controller, so the memory usage by the KubeVela controller is also reduced as well. Okay, so that's something we have done for the performance tuning. And we have also enhanced dry run command. So in the past, when we firstly developed the dry run command, it works for the application that has the component part and the trait part. But since version 1.2, and we add lots of new features, including the workflow part and the multi-cluster deployment. So since these things use the topology policy and override policy, and also the workflow part to orchestrate the resource delivery, so the old Vela dry run commands cannot fully satisfy the need for the multi-cluster resource dry run. So in version 1.7, we made some enhancements so that the dry run command can recognize the multi-cluster topology policy, the override policy, and the workflow steps, so that it can better satisfy the dry run needs under the multi-cluster scenario. And also, we have some enhancements for the resource dispatch. So from 1.7, we have a feature gate default enabled, which called pre-dispatch dry run, which means before all the resources needs to be dispatched, it will first call the dry run request to the Kubernetes API server to check if the request is valid. So sometimes if you find that the remote cluster is disconnected or the authentication is being forbidden, so for this time, at this time, you will see that the dry run check will prevent the user from doing that things. And instead of recording these things in the resource tracker, which can cause potential trouble when you try to run the garbage collection. So this is also an enhancement for the application controller. And we have also a new command in the Vela CLI, which is called interactive resource delete. So we find that usually the application deletion for the KubeVela works properly, but there are times that the application deletion could be blocked because the KubeVela controller has a very strict check for the deletion. For example, it will make sure that all the resources under the control should be removed from the cluster, and then the application should be removed. So there are times that users find that the application cannot be deleted, but they do not actually know why it is blocked. Although most of the time these things are recorded in the status field of the application, but since the status field of the application is growing a bit large, so users can sometimes get confused with that. So with the interactive resource delete mode, it means that the user can leverage the Vela CLI command to get fine-grained deletion for the application. It can control which specific resource he would like to remove from the application. So with this feature, you will gain better control for the underlying deletion of the resource. And also we have some enhancements for the authentication and the authorization part. So when we integrate the KubeVela's authentication mechanism with Vela UX, we find that there are some difficulties for you to enable add-ons because we have very strict privilege checks, so that usually the design users will not have the privilege to enable add-ons. So when the authentication is enabled, it is hard to directly enable add-on from Vela UX. So we made some improvements. The improvements is basically based on one of the enhanced feature for the cluster gateway, which manages the multi-cluster connection. So we have some advanced configuration for the cluster gateway, which allows the identity between the hub cluster and the managed cluster to have more rules to configure. For example, in the past, when a user tried to make some action, his identity in the hub cluster will be directly passed to the managed cluster. For example, when his name is Alice, he will also act as Alice in all the managed clusters. But sometimes we might want Alice to have another identity. For example, in some of the cluster, for example, in some of the Chinese cluster, he might have a name. He might have a Chinese name, but then the identity of Alice will not be recognized in that cluster. So with these new features, you will be able to customize the identity mapping between different clusters. Okay. And also there is some integration for the component orchestration with multi-clusters. When we use multi-cluster delivery, we usually use the deploy workflow step to deliver the resources. And there is another function, there is another capability in KubeVela named as data input and output. It means that when you have two different components, and one of the components will return something after dispatched, and the returned thing will be passed as the input to the next component. This could be happen when you have, for example, when you have one is the cloud resource that will create some secret, and the other one will consume that secret to make connection to the cloud databases. So the data input output can be very useful in this case. But for multi-cluster, when the deploy workflow step is used, we previously do not support the data input output between components. So now we have this feature enabled in version 1.7. And besides, we have also some enhancements for the add-on installation. That's like Helm chart. We can add some notes to the add-on installation, which will help the add-on users to know what the add-on designer wants them to use. For example, you can enable some add-on, and the add-on will prompt some message for the user to guide them how to use the add-on when it is enabled. So it will help the user to use and understand the add-on usage. And finally, we also have some enhancement for the KubeVela's workflow, which is for the workflow run particularly. So previously, the Vela workflow command can only work for the Vela application. And for workflow run, since they have very similar working mechanism, so the restart command can also work for other things. For example, they can work for the workflow run. But previously, when we change this behavior, we find that there is something changed in the application. So here we recover the support for the restart for the application. And also we support to restart a specified step as well, which means you can manually specify a workflow step to only restart that step instead of the whole workflow. Okay, so this is generally what we have in the version 1.7 in KubeVela. And for version 1.8, we are still in plan, and we are designing some new features we would like to introduce in version 1.8. So for now, I think there is something we are in developing, including two parts. One of the parts is that we are making an upgrade for the execution engine. But that is not determined to be introduced in version 1.8, maybe 1.9. So with the enhanced queue execution engine, you will be able to add customized functions to your queue script, so that you can have better expression in your queue files. And another enhancement we would like to introduce in version 1.8 is that we will probably support multi-replicas for KubeVela's core controller. So we found that there are some enterprises that uses KubeVela in production, and there's thousands of, even tens of thousands of applications that are being used in the production scenario. And we found that the core controller could be a bottleneck for the whole system. Although there are ways for system operators to increase the resource given to the KubeVela controller, for example, using more CPUs and more memories and using more threads for concurrency. But there are still some limitations for these strategies. So in version 1.8, we would like to introduce a sharding strategy for KubeVela core controller, which means that you can have multiple KubeVela controllers working concurrently for different partition of applications. So in that case, you will have better control for the scaling of your whole system. Okay, so that's something we would like to introduce in version 1.8 for now, but we might add more features if there is new feature request in the community raised. Okay, so that's all for the introduction. And I would like to have a very brief demo for the vela adopt command. And I will, so the vela adopt command is also written in this article, which called resource adoption. And you can find it in the official documentation site now. It's located in the version 1.7. And the first part of this article is about how to use the resource policy, including the read-only and takeover in the application YAML file. For example, you can here see that you just only need to add the policy in the application spec so that you can directly interact with the application CR. And we have also the second part, which is what I'm going to demo, is that how to use the vela adopt command to help you to manage existing resource in your cluster. So let's start. So the first part, we will see that there are something we have already running in the cluster, and we can see that there is no application for the cluster for now. But the KubeVela has already been deployed in this cluster. And yeah, I think my cluster is also a bit slow for connection. And we can see that we have prepared some deployments and config maps and secrets. And we will so these things are what we already have in the cluster, and also we have the service. We have the example deployment, example service, and the secrets and the config map. We would like to adopt all of them into one application. So let's run this command. So this command is that the command of vela adopt will specify the resources you like to adopt, for example, including the deployments of example and service and config map and secret. So when you run this command, it will automatically generate an application. The application is a bit large. Let's make it in the app.yaml. And you can see this application. It includes some components, and these components will try to dispatch those deployments and service and the config map and secret. And at last, we have the automatically generated read-only policy, which selects all the resources we have just embedded in the component part. So with this adopt command, you will get a auto-generated application. So if you want to apply it in the cluster, you can use the --apply flag. Okay, so the application is now deployed in the cluster, and we can use the vela status command to see this application. Yeah, you can see that all these resources and related services are healthy now because they have been deployed in the cluster for some while. And we can also use the tree detail flag for seeing all the underlying resources the application is currently managing. Yeah, and you can see that's what we have in this application. And we can also use the vela top command as well. I think the connection is not very fast, so we might need to wait a few minutes. Okay, so you can see that from the interactive top panel, you can see that not only the deployment is healthy, you can also see the underlying pods and the replica set. I think I just click something. Okay, yeah, so for the service, there is also some related endpoint slices and endpoints. You can see that in the resource topology graph. So in addition to the vela top command, you can also view this application on Vela UX or on Grafana as well. And so that's a very simple case for the adoption for the read-only case. And you will see that for read-only application, there is it will only observe those resources and do not modify them. So for example, if you try to delete this application, and the resources underlying will not be touched. So the example deployment still exists. And if you want to make hard adoption, you can add the mode command, mode flag for the takeover. Yeah. So let's first check out the application spec. So you can see that instead of using the read-only policy, it will use the takeover policy here to specify that these resources are going to be taken over, and you can have the garbage collect policy and apply once policy. These are automatically generated for special resources. So if you have something working as a custom resource definition, so the auto-generated application will not try to garbage collect them or use state to keep them. Okay, so now let's apply it in the cluster. Okay, so the application is deployed. And when you have this application, you can, since the resources have been taken over in the application. So you can actually make modification for them. For example, you can change the replicas for the deployment or change some spec for the service. Both are okay for that. And I would like to show you what you can do with that. So this is a main component, and we can add extra trait for it. So I think we do not need to have too much trait for it for now. We'll use the scalar trait, and the properties will use replicas 3, and I think we need to remove this one. So let's check the application, and let's check out the deployment. Okay, so we have just add a scalar trait which specify the replica number of the what we have adopted, which is the deployment. So it gives you a way to easily modify the existing resources or attach new capabilities for them. So with this application, you can leverage all the OAM applications capability to manage the resources. And if we delete this application, and compared to the read-only mode, you will find that the resources will be deleted because these resources have been taken over in the application. Okay, so that's one of the demo for the resource adoption for those native Kubernetes resources. And there is another cases we often see that user trying to do is that they use the helm helm to deploy some resources. For example, let's use helm to install a MySQL instance in the cluster. So when you deploy something in the Helm chart, it usually will usually includes multiple resources, and you can check it through the helm ls command. And you can see that there is the I think it's not the deployment, it's the stateful set. Okay, so there is a stateful set named MySQL in the cluster, and you can see there are pods, and I think there is also some config map for that. Yeah. Okay, so let's see what we can do with the vela adopt command. So this documentation has some typo here. This is vela adopt MySQL. So this is a helm chart's name, and we add the double dash type helm, which identifies the resource to taken over are from the helm chart. And we can see that the application is also automatically generated, and the resources under the helm chart is being adopted in this application. And it works in the read-only mode, as you can see. And we can also use the takeover mode to take all the resources under the Helm chart. And we can use the apply command to apply this application in the cluster. And there is also a flag named recycle, which means that you can, this flag means when the adoption KubeVela application has been successfully deployed, the underlying Helm release will be deleted so that you will only have one of the source of truth for managing resources. Okay, so let's try it. It will wait for the application to be running, and it will successfully clean up the old Helm release. So when you use Helm ls to see the chart, and we will not find the MySQL Helm chart anymore because this one has been converted into the KubeVela application now. And you can see that the related resources are running, are still existing. I'm not going to say it is running because there might be something bad for the cluster. Because we by default we are using the we are not using the web service component, so the health policy check will not take effect. And we can also check out this application. So this will show all the resources are being managed by the KubeVela application now. And these resources are all from the Helm chart previously. And you can see that the Helm chart actually deliver different service and use a stateful set and have some secrets and config map for it. Okay, so when you try to delete this application, so what also happens is that all the resources here are deleted. So if you go to see, if you go to see the resource, and they are deleted, and you will not see the MySQL secret or stateful set anymore because they are deleted, accompanied by the application's deletion. And finally, there is also another extension for the vela adopt command. It's called customized adoption. And as you can see that when we run vela adopt, in KubeVela application is automatically generated based on the resource we have in the cluster or what we have given for the command. And the adoption usually is usually associated with some conversion rule because you need to make some native Kubernetes resource into a KubeVela application. So the conversion process is actually could be customized, and it can be achieved by writing some queue templates, and this queue file will specify how the adoption should be done. For example, there are args. The args are the parameters and also the resources that are going to be adopted in this command. And the returned is the application, which is what we would like to generate. So you can make some customized logic here. For example, in this adoption rule, we will recognize the deployments and convert them into a web service type component. So in this case, you will have a very dedicated scenario adoption. Yeah, so you can use this rule by running the vela adopt with the adopt templates parameter. So you can see. Let's try it. For example, we can create a simple. Okay, so this deploy we have created before, and I have prepared this my adopt rule, and you can see this is a queue template for converting this. Or in other users' words, it's called decompile the resources into KubeVela application, and we can now run this command to adopt the deployment into the application. Okay, so now you see that the application is generated, and instead of using the Kubernetes object typed component, it will use the web service type, and also it can recognize the replica field and convert it into a specified trait. So this is what you can do with the customization. And that's all for this demo. And thanks, everyone. And let's see if there is any questions.
Can I just say, Dan, that looks really good. And I don't have a question because you beat me to it, which was how can you adopt into web service all the traits? And you've already thought of that and implemented it. So it looks really good.
Okay,
that's all I want to say.
Yeah. So the conversion rule here is very simple, but I think in different scenario, people are usually want to have more advanced customized rules, but that might be hard to be applied in all the scenarios. So we make the extension. Yeah.
I like that. I wondered if there was going to be some way where you had to, when you defined a web service, you had to, give it a kind of adoption pattern so that it could try and detect itself. But actually, the way you've done it is, of course, easier and yeah, is a better way of doing it, I think.
Yeah, we actually have discussed this as a very similar idea before. Is that in some users that propose that we can have all the deployment into web service by default, and since we have the read-only policy here, so we can, like by default, we can make all these applications automatically generated, and they will not touch the deployment. But once you would like to make this touchable, you can change the read-only policy to take over, so that you will have a very unified view for all the resources in the Kubernetes cluster, and all from a KubeVela applications view.
Yeah, it's good. Thank you.
Yeah, well, we all come to a very new idea, and maybe your idea could be put it in the new design.
It was my first thought. I'm not sure it's a good idea.
Yeah, I think it's.
What if you have, because I have a custom web service that I have defined, because it just has a few, I have to add a brand label, so I've added that as part of a custom one. How would, if you did it as part of the definition, they would be fighting. So maybe the web service and my web service would both think they could adopt it into their own type. I think you get into those fights, which is why I think the way you've done it is actually better. Yeah.
Cool. Thanks for that. Let's see if there's any more questions. Okay, so Fogg, are you still here?
Yeah. Okay. So if there's no more questions, I think we can end this meeting. So thanks, Star, for your amazing demo, and thank you everyone who's joining us today. And the recording of the meeting will be uploaded to YouTube after the meeting's over. Okay. So thank you, everyone. Bye.
Goodbye.
Thanks. Bye.
Thank you. Bye.
Bye.